Okay, as promised, I'm going to show you a couple of examples of equalities where we have linear expressions, variable expressions in the denominator of fractions. Okay, so my first example is going to be 3 over 5x plus 1 over 5 is equal to 1 over 2x. Okay, the first thing I want to do here is I want to get a common denominator. Okay, so just like in elementary school or high school, when we get a common denominator, we want to factor the denominators of each of our individual fractions into their prime components, and then we figure out what we need in each of them that they don't already have. Okay. So here, 5x, this factors into 5, which is prime, times x, which is a simple linear expression. So we're going to have 5, and we're going to have x. Okay, here we've got 5. Well, we've already got 5 in our denominator, so we don't need to put another 5 there. We'll just multiply this one by x. Now we've also here got 2 and x. We've already got the x, but we need the 2, okay? So our common denominator is 5 times x times 2, which is 10x. Okay. So now, in order to get the common denominator, we need to multiply by the form of 1 that gives us the common denominator for each of these fractions. Okay, so here we have 5x, we're missing 2. So I'm going to multiply by the form of 1, 2, right? So 2 over 2, that's 1. I can always multiply something by 1 without changing it. I just am picking a specific form of 1. Okay, so I got 2 over 2 times 3 over 5x. Okay, now here I got 1 over 5. I'm missing the 2 and the x. So I need to multiply by 2x. So I'm choosing the form of 1, 2x over 2x times 1 over 5 is equal to, now over here I've got the 2x, I'm missing a 5. So I'm going to multiply by the form of 1, 5 over 5 times 1 over 2x. Okay, now we simplify. We end up with 6 over 10x plus 2x over 10x is equal to 5 over 10x. Okay, simplifying further, I can add these together. There are two fractions with a common denominator. So I just add the numerator over 10x is equal to 5 over 10x. Okay, now on both sides I've got 10x, so I'm going to multiply both sides of my equation by 10x. Okay, so this is going to cancel these out, right? Okay, and then I'm left with 6 plus 2x is equal to 5. This is a linear equality, very easy to solve. So we subtract 6 from both sides. We get -1. Now we solve for x by dividing by 2. We get x equals -1/2. And that's our answer. Okay, so just to recap, what did we do? We found a common denominator. We made sure that our fractions all have the common denominator by multiplying by the proper forms of 1. Then we simplified. We got rid of the denominator by multiplying both sides of our equation by the same number. And then we solved, notice this simplified to a linear equality, excuse me. So we have a linear equality that was really easy to solve. Okay, the second one is actually going to end up being a quadratic equality. So this example is 3 over x plus 1 minus 5x over 6 is equal to 2 over 3x plus 3. Okay, again, let's go ahead and factor the denominators. This time I'm going to write it out. So 3, now x plus 1, that doesn't factor, right? That's just a simple linear expression. Minus 5x over, we can factor 6 into its prime factorization, which is 3 times 2, is equal to 2 over, I can pull a 3 out, I can factor that 3 out, And then I have 3, which is prime, and x plus 1, which is a simple linear expression, so I can't factor that further. Okay, now let's find our common denominator. Okay, so we need an x plus 1, definitely. Okay, we're also going to need a 3 and a 2. Okay, now notice then when we look at this one, we've got 3, that's already there. We've got x plus 1, that's already in our common denominator. So this is our common denominator. It's going to be 6x plus 6. Okay, now we just need to choose the right forms of 1 to multiply each of these by to get the common denominator. Okay, so here we've already got x plus 1. We need to multiply by 3 times 2, which is 6. So I'm choosing the form of 1, 6 over 6 times 3 over x plus 1. Okay, here I've already got the 6, but I'm missing the x plus 1. So I multiply by x plus 1 over x plus 1. Okay, and then over here I've already got the 3 and the x plus 1, so I'm just missing the 2. So I multiply by the form of 1, 2 over 2. Okay. Okay, now let's go ahead and simplify. We get 18 over 6x plus 6 minus, this is going to be 5x squared plus 5x over 6x plus 6 is equal to 4 over 6x plus 6. Okay, let's simplify further. These are two fractions with a common denominator, so I just add their numerators. Now this minus applies to both parts of both terms in this expression. So I have minus 5x squared minus 5x. The minus distributes over 6x plus 6 is equal to 4 over 6x plus 6. I multiply both sides of my equation by 6x plus 6. That cancels the denominator. And I end up with 18 minus 5x squared minus 5x is equal to 4. Now if we simplify that, that's going to be a that is a quadratic equation, but if we simplify it, it'll be in our blah 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 equals 0, just like we like. So I'm going to move everything over to this side. So I get 0 equals 5x squared, positive 5x squared, I add it to both sides, plus 5x. And then I have 4 minus 18, which is negative 14. Okay. Now, of course, this is exactly what we want. We have A is 5, B is 5, and C is negative 14. So if we use the quadratic formula, we get that x is equal to negative b, which is 5, b is 5. So negative 5 plus or minus the square root of b squared, 5 squared, which is 25, minus 4 times a is also 5, times c. Now c is negative 14, okay, all over 2a. Now a is 5, so 2a is 10, okay? So this is our two solutions. So one thing to note, before our equality simplified into a linear equality and we ended up with just one solution. Now our equality simplifies into a quadratic equation and we have two solutions. These are two distinct solutions, the plus solution and the minus solution.